Assalamu alaikum. Now, with the 28 students, we are starting this lecture. So, title of the lecture is Influence Lines for Bending Movement. So, I'm going to share the lecture notes. First of all, the sign convention for positive bending movement. Now, any force which produces tension at the bottom fibers of the beam is considered as positive bending moment and vice versa. Now, this is the conventional direction for the positive bending moment. Secondly, the bending moment in beam is associated with a particular section within the beam, as we have already discussed it yesterday. Computation of maximum bending moment at a particular section within the beam for moving load is also based on the same two steps. Step 1 is drawing of influence line diagram for bending moment for unit moving load. And the second step is determination of critical location of actual moving load, either by trials or by judgment or by the combination of both or by the mathematical criteria, where it will give the maximum value of the bending moment and then the computation of the value of the maximum bending moment. Same two steps. Now we will learn with an example of a simply supported beam where we have to compute the maximum bending moment at section Mn for the standard truck loading. Now on the right side, this is a simply supported beam with two supports, support at A, support at B. And section Mn is defined at a distance small a from support A and at a distance of small b from the support B. Now step 1, drawing of influence line diagram for unit moving load. The simplest method is as follows. When this unit moving load is on the right of the section, like this, so the bending moment at the section Mn, considering this left portion, will be equal to Ra into A. Bending moment at section Mn, considering this left portion, will be equal to Ra into A, and this will be positive because it is creating tension on the bottom fiber. So similarly, when this unit moving load comes on this left portion to the section, and the bending moment at section Mn will be equal to Rb into B, considering this right portion, and since it is also creating tension on the bottom fibers, so this value will also be positive. Now we have to draw the two influence lines, one for Ra into A, then second is Rb into B. Similarly, this you can see that this straight line 0 at B and A at A. Now what was in case of reactions? There was 1 instead of A. Now this is the moment, force into distance. So this will be equal to this distance A. So this will be the influence line for Ra into A. Similarly, this influence line will be for RB into B. And this ordinate will be B. In case of reaction, what it was 1. Now that was a force. Now it is force into distance. So this rotation is A over L. This rotation is B over L. Now, alternatively, what we have to do, that is the base, we can give a unit positive rotation. Unit positive rotation mean this rotation, theta 1, and this rotation, theta 2. Theta 1 plus theta 2 must be equal to 1. This is called unit rotation. So, alternatively, based on virtual displacement method, giving a unit positive rotation, and the resulting configuration will be the ILD for bending moment at section MN. Now, this ordinate under the section will always be equal to A into B, the product of these two distances divided by the total span. This is always. In this case, this slope is A over L. This A over L into this horizontal distance, that is B. So AB over L. If we move from this support A, this slope is B over L, and the distance of section from support A is A. So this ordinate is this slope into the distance, that is again AB over L. The similar is here. This theta 1 is B over L, and this distance is A, so this is AB over L. So unit positive rotation, and the ordinate under the section is always the product of these two distances divided by the total span. So any question? So we move to the second step. We have to determine the maximum bending moment at the section for standard truck loading. Now considering this A as 4 meter, B as 14 meter, the same beam as we have discussed yesterday, and the total span is 18 meter. Now again, this is the ordinate under the section, which is the biggest ordinate. So it should be multiplied with the heaviest load. So by judgment, it is clear that bending moment at section MN will be maximum when wheel 2 is at the section. However, if you are not able to make the judgment very correctly, you can make the trials. So Mmax will be this 16 will be multiplied with this 0, so it is 0. So this 64 into 4 into 14 divided by 18 plus this 64 into 4 into 10 over 18. So this will be 341.312 kilonewton meter because it is a moment. So the unit will be kilonewton meter. Now similarly for standard train loading, you can start trial from wheel 2 at section M and then check for wheel 3 at the section. Now look at this. Wheel 2 is at the section. This will give us 1380, and of course you know that how to compute these ordinates corresponding to these loads with the help of these horizontal distances and this slope, which is 4/18, and the slope at A is 14/18. So with wheel 2 at the section MN, the value of the bending moment is 1380 kilonewton meter. So a similar trial shall be made when wheel 3 is at the section MN. I think you do it just now. Put the wheel 3 at section MN and compute the value. Please hurry up. When you place wheel 3 at the section MN, wheel 1 will be outside the beam. Anybody who has computed the answer? G, anybody who has computed the answer? इतना टाइम नहीं लगना चाहिए. G, Mr. CR, what are you doing?
Yes, sir.
आपने जवाब निकाल लिया है?
नहीं सर, कर रहा हूँ.
वो इतना टाइम तो नहीं लगना चाहिए. ये सिंपल एक लाइन का इसका जवाब है.
Sir, 1431.11.
नो. इसका जवाब जो है वो 1380 से कम होना चाहिए.
1319.
जी,
1319.
इसको चेक करें, इसको चेक करें. ये मेरे पास थोड़ा सा फर्क है. इसकी जरा कैलकुलेशन जरा चेक करें.
सर 1325 मेरा आ रहा है.
आपके चारों के चारों 80 के व्हील लोड्स ऊपर आ रहे हैं. जब 60 का व्हील लोड निकल जाएगा तो जो एक पहले बाहर है 80 किलो न्यूटन का, वो इन हो जाएगा. वो आप क्यों इग्नोर कर रहे हैं? When wheel 3 will be at the section, wheel 1 will be out and wheel 9 will be in. जी गर्ल
सर
स्टूडेंट्स क्या कर
1320 की बात है।
जी 13
20 ऑलमोस्ट सेम ही है, एक पॉइंट्स में डिफरेंस है।
पॉइंट्स का इशू नहीं है, हर बंदे का डिफरेंट आंसर है। अब ये कोई कैलकुलेशन है जो बड़ी मुश्किल कैलकुलेशन है ये। जी गर्ल स्टूडेंट्स का ने क्या जवाब निकाला है? या सारी की सारी रेस्ट मोड में है? कोई हाल है आप लोगों का? जी सीयर व्हाट इज योर आंसर?
सर आप कोशिश कर रहा हूँ, पहले आया था 1925, अब कोशिश कर रहा हूँ दोबारा मतलब सॉल्व करने की।
नहीं ये कोशिश कोई इतनी एक्सटेंडेड कोशिश है कि इसको इतना ज्यादा टाइम लगे? आपने
सर
जस्ट इन लोड्स को, वी लोड्स को उन ऑर्डिनेट के साथ मल्टीप्लाई करके जमा करना है। इससे ज्यादा कोई आसान चीज हो सकती है? ना प्लीज हरी अप। ये गर्ल स्टूडेंट अपने कैमरे ऑन करें।
सर 1355.55 आ रहा है मेरा।
अब बस ये करीब आ गया लेकिन ये एग्जैक्ट नहीं है। करीब आ गया लेकिन एग्जैक्ट नहीं है। जी 135 1355 बहरहाल मेरे पास ये जो वैल्यू है ये 1351 है। इसको जरा एक दफा फिर एक दफा देख लें कि कहीं कोई थोड़ी बहुत एरर तो नहीं है। ये चेक कर लें इसको अगेन। Anyhow, we are proceeding ahead. With your extremely poor performance, what I can comment else? अगर आप ये सीधी सीधी ज़रबें नहीं दे सकते तो फिर आप क्या कर सकते हैं? So now we have to repeat the same problem for same loading by introducing overhang portion on each side of 4 meter each. A and B the same span, same beam, but with the overhang portion on left and right side, each of 4 meter. Now, step 1 is quite similar for portion AB. Now, for this portion AB, the influence line diagram is 100% same. Just you have to extend these lines up to the overhang end on each side with the same slope. This will be the shape of the ILD for bending moment at section MN for this overhang beam. Now step 2 is the computation of the maximum bending moment at the section MN for standard truck and train loading. ये आप कर लेंगे या नहीं कर सकेंगे? It is same as the above problem but with the overhang portion. जी मिस्टर सी जी ये आपको करनी चाहिए प्रॉब्लम, इसमें और कोई रॉकेट साइंस नहीं है. बट one wheel must be at the section, ये mandatory condition है. Now we will learn how to use the mathematical criteria. गो के इसकी अमूमन नौबत नहीं आती है. Now look at this simply supported beam, और ये जो mathematical criteria हैं they are feasible for simply supported beams. Now section MN at a distance small a from support A, and section MN is at a distance of small b from support B. Now what we do, this is the influence line diagram, same concept. What we do, we compute the average load on each portion, right portion and left portion. Now what is the average load? Average load mean the sum of the wheel loads on this portion B having the span small b, sum of wheel loads divided by this distance small b. This will be the average load. Whereas the average load on the right side is the resultant of or sum of the wheel loads on this portion divided by this distance small a. Now, if trials or judgment or combination of both is not working, then the third option is to use mathematical criteria. We compute the average loading on the right and left portions of the section. RR is the sum of wheel loads on the right of the section. RL is the sum of the wheel loads on the left of the section. RR over B and RL over A are the average loads on the right and left portions of the section, respectively. Now, as long as the average load on the right portion is greater than the average load on the left portion is valid. For each advancement of the wheel load, the bending moment at the section will keep on increasing. The wheel which reverses this condition will be the load that gives the maximum bending moment when placed at the section. ये ज़्यादा simple है as compared to shear force के. So similarly, yes, there is another situation. If average load on the right portion is exactly equal to the average load on the left portion, then we have to check for both wheel loads, and larger of these two values will be taken as maximum bending moment. Now in case of UDL, this is a little tricky. वो तो बहुत simple apply करना, ये थोड़ा सा tricky है, इसीलिए इसकी example भी साथ आपको करा दी गई है. Now look at this. This is a UDL having the intensity Q. Now we have to place this UDL in such a manner that the maximum bending moment will occur at the following condition: when A over C is equal or nearly equal to B over D. This is C and this is D. Now we have to adjust this UDL on the section in such a manner that A over C should be nearly equal to B over D. Now the example is considering A is 8 meter, B is 12 meter, Q is 25 kilonewton meter, and surely the span is 28 plus 12, 20 meter. Now, in order to have the maximum effect of UDL, we have to place the UDL in such a manner that the condition A over C is nearly equal to B over D is met. A and B are known, whereas C and D are to be determined by trials. अब देखें हम trials कैसे करेंगे. Trial 1, ये hit and trial है, या अगर आपकी ज्योमेट्री पे बड़ी ज़्यादा ग्रिप है तो आप hit and trial को उसकी एफर्ट को रिड्यूस कर सकते हैं. So if we take C as 2.5 and D 3.5, it will become 8 over 2.5, 12 over 3.5. It will become 3.2 and 3.43, not nearly equal. So we proceed for next trial. Then we go for 8 over 2.4 and 12 over 3.6. It is exactly the same. So now we will place C 2.4 and D 3.6. Now maximum bending moment at the section MN will be equal to the intensity of the UDL multiplied by the area of ILD under UDL. This is the shaded area. So this intensity multiplied with the area, this shaded area of the ILD under UDL. So these ordinates you can determine very easily. These are the C and D are the horizontal distances. So it is very convenient to determine the area of this ILD. This has been computed here and its value becomes 612 kilonewton meter. इसको आप फिर देख लें. If you have any question, you can ask. So I think it is clear. So now we proceed for absolute maximum bending moment. We have studied how to compute maximum bending moment at a particular section of a beam. Absolute maximum bending moment is the maximum possible bending moment in a simply supported beam anywhere. वो था किसी सेक्शन के ऊपर मैक्सिमम बेंडिंग मोमेंट. अब ये है कि इस maximum possible bending moment in this beam. This is the difference. It always occurs near the midspan of the beam. दो चीजें हैं ना, कहां पे और किस व्हील लोड के अंडर. These are the two questions. Where it occurs and under which wheel. So first question जो है, where it occurs, it is known that it is always near the midspan. Exact location has to be determined. But definitely, surely we know the wheel. Under the wheel, which gives maximum bending moment at the midspan. Same wheel होगा जो कि midspan के ऊपर maximum bending moment देगा. So firstly, we will determine that which wheel will give the maximum bending moment at the midspan. Then that wheel will be selected. Then we will proceed where the absolute maximum bending moment occurs near the midspan. Since the wheel is known, which will give the absolute maximum bending moment, but its exact location near the midspan is to be determined. Is it clear to you what is the difference between maximum bending moment at a section and absolute maximum bending moment? Now we learn it with this example. This is a simply supported beam of 18-meter span, and the midpoint is the point C. Now the question is determine absolute maximum bending moment for the simply supported beam subjected to following moving load. There are three wheel loads. First is 20 kilonewton, 40 kilonewton, and 40 kilonewton. The distance between wheel 1 and wheel 2 is 4 meter, and the distance between wheel 2 and wheel 3 is 8 meter. Now, first of all, we will determine that which wheel will give the maximum bending moment at the midspan after drawing of ILD for unit moving load at the midspan. Step 1 as usual. So for midspan, this is the ILD for bending moment. This is half, this is half. Sum is the sum of these two rotations is 1. So this ordinate under at the midpoint is sum of these two, remember, product of these two, 9 and 9, 81 divided by this total span. So for this ILD and this loading, it is very convenient to assess, to judge that wheel 2 will give the maximum bending moment when placed at the midspan. Ye wheel 2. By judgment, it is evident that wheel 2 when placed at the midspan will give the maximum bending moment at the midspan. Its value will be 20 into 5 by 2. This 20, इसका जो distance है वो ये चूंकि ये दूसरी इसकी लोकेशन है, ये इस वक्त मिड स्पैन पे है, तो ये 4 मीटर है, तो ये 5 मीटर हो गया इधर वाला। सो 5/2, 5/2 into 40 into 81/18 plus 40 into 1/2, 1 into 1/2. So this is 250 kilonewton meter. Now this is the maximum bending moment at the midspan. Absolute maximum bending moment will be greater than this. The value of the maximum bending moment will be more than this value. Now wheel 2, when placed near the midspan, will give the absolute maximum bending moment. Now we have to find this location in an exact manner. Now before proceed further, अभी तक कोई question है तो बताएं. Now this wheel 2 is at a distance of x near the midspan, x, and this is 18 minus x. आपने चूंकि ये x की वैल्यू मालूम करनी है और ये हमने इस wheel 2 को near the midspan रखा है. We don't know what this value of the x is. This is yet to be determined. Now, let's wheel 2 is at a distance x from A and the value of x is to be determined. Now, taking moment about wheel 2. By considering the left portion, this portion. This will be RA into x. Now, आप यहाँ पे wheel 2 के about moment ले रहे हैं. RA into x minus 20 into 4. Again, RA into x minus 20 into 4. RA because it is creating tension at the bottom fiber, and 20 into 4 because it is creating tension at the top fiber. That is why it is taken negative. Now in this expression, RA is unknown. Now in order to determine RA, the usual procedure is taking sigma MB0. Sigma MB0. Now you are taking moment about B. RA into 18, RA into 18 minus these three loads. First is 20, अब 20 तक distance कितना है? This 18 minus x plus 4. B से 18 minus x plus 4. Then 40 into 18 minus x. Then 40 into 18 minus x minus 8. Is it understandable? Taking moment about B, RA into 18 minus these three loads. The distances are from B 20 into 18 minus x plus 4. 40 into 18 minus x. Then 40 into 18 minus x minus 8. You will get this distance. So the same expression I have written here. Now RA, divide this expression by 18. Now put this value of RA into this moment expression. This will be, upon simplification, it will become 86.66x minus 5.55x square minus 80. Now you must have studied the maxima and minima. Maxima and minima. So dm over dx must be equal to 0. Now taking its direct derivative with respect to x, so it will be 86.66 minus 11.11x. So the value of x is 7.80 meter. So midpoint is at 9 meter. So value of x is 7.8 meter. Now substituting the value of x in the moment expression, ये moment expression आएगी, this one. इसमें x की value आपने substitute करनी है. And you will get the value of the bending moment, absolute maximum bending moment, that is 258 kilonewton meter. Now, any question you have in your mind regarding this problem? Or any confusion? जी कोई क्वेश्चन आपका? यार लगता है आप सारे स्लीपिंग मोड में हैं. Anyhow, this is the same problem but with different loading. Now I would like you proceed with it yourself. करें इसको, सेम कॉन्सेप्ट है.